everyone. Let's start with, again, forces. We started yesterday and we looked at two vectors and we had to get the resultant or the net force of those two vectors working together. So what is again a resultant? That gives you the same effect as the other two working together. So it is that one vector giving the same effect as the other two vectors working together. Now what we're going to do today is we're going to now say, no, I'm going to give you one vector at an angle, and you will have to find the components in the x and the y plane that made up that resultant vector. So we're going to go the other way around. So let's have a look. Let's say I give you one vector, let's say magnitude of 10 Newton, and I do give you a 30-degree angle to, of course, the x-plane. Now you have to find, and now of course this is all mathematics, so I hope you have done it already at school. So in maths, so let's see, okay, if I have to break this down, this single vector, in an x component, what I'm going to do is I'm going to leave a line down, and I'm going to just draw a 90 degrees to that line. This will then be my fx component. And I'm going to do the same towards the y plane. So this is my y plane, this is my x plane. And I'm going to do the same thing here, 90 degree line to that point. And I'm going to draw in my fy component. And actually, the moment I do that, and that is why I did it in a different color, although they're very strict when they mark that. So they don't actually want us to draw all three vectors at the same time. Why not? Because that will show actually these three vectors, and it's not. It's either these two, and they will, of course, result in a net force in that direction, or it is that force and I just get it as two single components. So the moment I draw the components in, I'm actually supposed to take the third one out. Or use it, maybe, some teachers would still allow you to leave it like that. Okay, so I've got my x component and I've got my y component. Now how am I going to calculate that mathematically? Now what I want you to do then is always work with the square that is adjacent to the x-plane. Then you don't have to first work out that angle and then you put all mixed up in maths. And I don't want you to do that. So we're going to work it very simple. I'm going to explain it once, and from there on we're just going to always use the same formula for the x-plane or the x component of my force or the y component of the given force. But let's use now, just to show you where it comes from, let's use just this triangle here. So what do we have there? We only have that value, 10 Newton, and we have this as 30 degrees. But I'm sure you notice you've got a perpendicular triangle. So I could now go and say, okay, what is this angle? And because I'm going to work out this one, I want to work out fx, I'm going to say this is the plane which is adjacent, or the side, to this angle. So I'm going to use cos theta equals, and in this case it's going to be the fx, the adjacent side, over that 10 Newton side, or the original vector f. So if I would want then to get fx would then equal, let's take that over and we can multiply that on that side. So it's f cos theta. And what is the value of f? It's 10 Newton, that's my original force that I had. Cos theta, in this case, cos 30 degrees. And let's work it out. So I think that would give us, okay, let's type it quickly in, cos 30 degrees times 10, and that gives me then Fx is 8,66 Newton. Now remember to always give a direction, otherwise you're not going to get your mark there. So what would then be my direction? It would be in the positive x-plane. So in that direction equal the x-plane. Alright, so let's see now how would I work out the Fy component. So if I'm looking at this one, remember that's the same, they equal that one to that one. I'm going to stay in this triangle, but now of course it's the opposite side. So what do I use for the opposite side? I'm going to say sin theta equals, and what am I looking for? I'm looking for the Fy. So it's Fy, because it's sin 30 degrees, Fy on that 10 Newton, which is my F, and I'm going to say, okay, so that means that my Fy equals sin theta times F. And sin theta in this case is 30 degrees, times that 10 Newton. I think that's going to give me 5. Let's type it in. 6 sin 30 degrees times 10, and it's going to give me 5 Newton. Now what would be my direction now? Now it would be either 90 degrees from the positive x-plane, or I'm just going to say 5 Newton, 0 degrees, or I could say upwards. So as long as you give a direction that makes sense to the person that's marking it, you need a direction. Okay, so now I do have those two, breaking them up in a Fx, so the force that's working in the x-plane and a force that's working in the y-plane. So I could break it up into two different ones. Now where on earth are we going to use that really? Now let me explain to you, what are we going to do if there's more than two vectors working on the same point? Let's say there's 3, and they work in different angles, and that I can't add. So for me to be able to add different vectors, I need them in an x-plane where I can either get the sum of them or subtract, or I need them in a y-plane. Alright, so that's what we're going to do. Now let's see how are we going to apply this. But from now on, guys, I want you to remember that whenever you want to work out the y component of a vector, you're going to use f sin theta. Whenever you're going to work out the fx component, you're going to use f cos theta. So I want you to keep that in mind, but, okay, just a warning, then you do have to work with the triangle that is sitting on the x-plane and not the one adjacent to the f-plane, to the y-plane. Right, now let's see, how are we going to use this now? These components, so the x component, the y component, where am I going to use that? Now here's a typical question. The question would look like this. Let's say you have a Cartesian plane. So there's your y and there's your x plane, and they do give you now different ones working. So they do give you now, let's say, a vector. Let's make it there 60 degrees, and let's make that 8 Newton. Working on a certain point. But they say there's also another vector or another force, let's make that 5 Newton, and I'm going to give you this angle as 20 degrees. And then they could even add another one, let's say working in this direction. And let's say I give you this angle as 10 degrees, and I give you this as a 7 Newton. So can you see that we now have 3 different vectors working on the same point, and we just can't add them because they're not working in the same direction or opposite direction. We would just say plus or minus. So what we now have to do, And it's actually very simple. It's just a long, systematically way that you have to do it. So, and I'm going to draw it in for you. What we now need to do is to take each vector and break it up in its x component. So that is my fx of the 8 Newton. And for that 8 Newton one, I'm going to also get the y component. So that's my fy component of just the 8 Newton. So let's start with just this one. Remember what we have to do is we work in this triangle. So immediately I'm going to say, and I'm going to break them up. I'm going to do my x components on this side and my y components on this side. So let's say for the fx component of the 8 Newton vector, what did we learn just previously? When I want this one, it's adjacent to the 60-degree angle, so it will be my fx, f cos theta. Remember what I said, if you work with this triangle, then you can always work with fx equals f cos theta, and the y component will always be fy equals f sin theta. Alright? So now we're going to say, okay, what is the value of the f, that's 8 Newton, cos 60 degrees, and I'm going to work that out. So it's 8 times cos 60 degrees, and it's giving me 4 Newton, of course, let's say to the right or in the positive x direction. Alright, so there is that one. Now I'm going to go and say for that 8 Newton, let's work out the fy component. So for my fy component of the 8 Newton one equals f, remember now, sin theta. So what is my f? It's still 8, but now it's sin and not that angle, still the same triangle, still 60 degrees. So let's work that quickly out. So that's 8 times sin 60, and that gives me 6.928. I'm going to keep it as 3 decimals, and only at the end I'm going to work it back to 2 decimals. Alright, so that is now done with the 8 one, with the 8 Newton one. Now I'm going to go over to this one. So you see, it's just very systematically that you're going to do it. Just stick systematically to your guns. Alright, so now I have a problem, and I hope you see what my problem is. I've got this angle as 20 degrees. So if I would want to work with this triangle, no, because otherwise my trick is going to be completely the other way around, and I don't want to always start from scratch applying my maths. So what I'm going to do is I'm going to say, now I want to work with an angle that will be adjacent to the x-plane. So this would give me the 90 degrees minus 20. So that angle is the 70 degrees. Alright? And if I work with that angle perfect, then I can go and say, okay, what is there is my fx for that 5 Newton with the fy. There's my fy for that 5 Newton one. But I'm just going to now again use my formula. So fx for the 5 Newton. Now remember now in this triangle there, which is perfect, because if I want my fx, my angle is still adjacent to my fx, so everything is the same, just as I had it there, it's just on this side. Okay, so it's going to be f cos theta. What is the magnitude of f? It's 5 newtons, cos, and we worked it out, 70 degrees, which would give me 5 times cos 70 and it gives me 1.71 Newton, again in the positive x direction. Alright, so now I've got the xf of that one. So, same thing here. Now I want to have the Fy, my y component of the 5 Newton force. So that would be my 5 Newton force, y component is then F, given already, and now it's sin theta. So you can see my Fy every time will be sin, my Fx would every time be cos theta. So you're going to remember it like that. Okay, so this would then be 5 sin 70 degrees. Remember, I'm working in that triangle. Even though I'm working out this one, I'm actually pushing it over and work it out there because it's the same size, or the same magnitude. Alright, so it's 5 times sin 70, and that gives me 4.698 Newton. Again, I'm going to leave it as that. Okay, now of course the last one, great, here I do have the 10 degrees towards the x-plane, so I'm happy. So if I draw my line here, there will be my fx, and there will be my fy. Now, just a second. When I now look back at this one, I didn't write the direction in here. And you see that one was upwards. So that's in the positive y plane. But this now becomes, when the moment we go under the x-plane, that would become a negative for my y component. So that's my positive y's, my negative y's. My positive x's, my negative x. Alright, so I'm going to put a minus in front of there. Okay, now for the last one, so we're going to say fx, for which one? It's the 7 Newton one. So it's f cos theta again. So we keep all the ones that's similar underneath each other. So it's 7 cos, in that case 10 degrees. So that's an easy sum. 7 times cos 10 gives me 6,893. Okay, let's do it 693 Newton. And in this case, now my x component is in the negative direction. So it's not a positive x, it's a negative x, in the negative x direction. And that's why I'm going to put a minus here to show that. Alright, so that's now all 3 of my vectors. I got all of them in the x direction. Then I'm going to do my fy. For my 7 Newton vector, same thing, f sin theta. Okay, we are getting it now, 7 sin 10 degrees. And of course that's going to be in the positive y, so it's 7 times sin. And that gives me 1.215 Newton positive. Now I want to show you quickly what has happened. What has happened is we broke down each of these original vectors into each different components, which means basically I can now remove them. They do not exist anymore. They only exist as an x component and a y component. So I'm going to use again the purple for the x components. So there's an x component, then this one had an x component there, and then the 7 Newton had an x component working in this direction there. And then for all the y components, we had that one going up, which was there. We had that one going up, which was there. And we had this one going down, so there was a component on the A plane going down like that. And what we now see immediately is that now I can add them. The moment I've got vectors working on the same plane, I can either add or distract. So what I'm going to do now is to say, alright, what is the total sum of all my xf components? And I'm just going to add them. So it's going to be plus 4 plus 1,71 minus 6,893, and that will give me just one x component. So 4 plus 1,71 minus 6,893, and I get minus 1,183 Newton. So basically this one is a bigger one than those two together. So if I now start to draw that, I would say, okay, if I do have my Cartesian plane again here, then that x1 would be laying there. And its size would be 1,183. So I've now taken all the x components and I have now only one left. Perfect. Now we're going to do the same with the y component. So we're going to say, what is the sum of all the y components? So I'm going to add them up. So it's 6,928 minus 4,998 plus 1.215. Alright, let's get the sum of that. And that gives me then a 3,145 Newton. I hope you can see that is in the positive direction because I'm ending with a positive. So that means I have now at the end actually only two vectors. So I've got one working in this way and I've one working upwards, which is 3,145 Newton. So don't worry, you're going to get a lot of marks for this because we need to mark individually every x component that you worked out correctly and every y component that you worked out already. There's already 6 marks. Then you have to add them up and add them up. So then we're almost already at 8 marks. So just keep going. We're almost there. We're not finished. Why? Because they've asked you for the one vector, the resultant vector of all 3 of those vectors working together. So at this stage, we only have 2 left. We still get to just get 1. So what are we going to do now? So, sorry guys, I'm just going to have to now take this out. Alright, let's start with a clean page. And we have our 2 forces now. After we've done all that work, we're left with a y component and an x component. And what we're going to now have to do is find the net or the resultant vector to just get 1. And so, there I'm going to just draw it in. Right? I'm going to again work with this triangle. That is with the x plane. And I'm going to now, I see now that I've got this one and I've got that one. So I've got the x and a y, and I'm going to use my Pythagoras again. So for my f resultant square, it's going to be the fy square plus fx square. So let's see what we can have. We're going to have 3.145 square plus 1.183 square. And let's see what that gives us. And that will be our final magnitude of our one single resultant vector. Alright, let's get that. So that would be 3.145 plus square plus 1.183 square, and I get my final answer 3.36 Newton. So that is only the magnitude. I still have to find my angle, the direction in which that net resultant force will be working. So I know that I've got the x and the y, so what I'm going to use is I'm going to use tan theta to get theta, my angle, which will be then the opposite side over the adjacent side, so it will be 3.145. You know, if I take that to there, that's the same magnitude, alright, over 1.183. So theta would be then tan minus 1 over 1.183. You don't have to show this. You can go immediately and just use your, I will just start with shift and then tan, and then 3.145 divided by 1.83, sorry, 1.183, and that gives me 69.39 degrees angle. Now I have to then say, if I measured it upwards from the negative x-plane, or again, I could just add 270 degrees to that, because if I start measuring from there to there is 90, 180, 270 plus that one, which I'm going to just do now, so plus 270, so that would be giving me the direction of 339.39 degrees, measuring all the way around to there. And that would be my final answer of a very long sum that I had to do. But like I said, guys, this do give you a lot of marks, so just work systematically. And always remember, from now on, if we want to work out the fx component, it would always be f cos theta. And if I want to work out the fy component, it would be f sin theta. Alright, that's it for today. I hope you did focus. Believe in yourself, you can do this.